Good afternoon, class. We are looking at Chapter 4, Linear Functions. Here's section 4.2, Modeling with Linear Functions. In essence, is the concept of word problem and applications. So we covered 4.1 linear functions and now modeling with linear functions. The objectives are build linear models from verbal description, model a set of data with a linear function. And we need to know the following: the slope, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Vertical line x equals a with sloping undefined, x-intercept at the a0. Horizontal line y equals b, m, the slope is 0, y-intercept at 0b. Parallel lines have equal slopes, different y-intercepts. Perpendicular lines, the slopes are negative reciprocal of each other. Lines, we can write them in three formats. Standard form, ax plus by equals c. Slope intercept form, y equals mx plus b. And point slope form of a line, y minus y1 equals m times x minus x1. So we looked at the concept of average rate of change of y with respect to x, which simply put means rise over run. So the average rate of change, the difference quotient delta y over delta x equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So if we look at the first one, the 2 points have coordinates that are used here, x sub 1, f of x sub 1, x sub 2, f of x sub 2. But you could write them, you could write them differently. So this is called the average rate of change of y, or f of x, with respect to x, over the interval of x sub 1, comma x sub 2, and can be interpreted as the slope of a secant line PQ. This blue line is known as the secant line. Now, this slope basically is rise over run delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We could write them in this format that was given. If you look at these pairs, and this is a comma f of a x comma f of x, it gives you this definition. If this point, we give them coordinates b, therefore f of b gives us this definition. And if you look at the last one, where the run is h, we go from a to a plus h, and the rise is f of a plus h minus f of a, gives us this definition, f of a plus h minus f of a over h, which is normally known as the difference quotient. But they all mean the same thing, as it's been explained before. All right, so build linear models from verbal descriptions. Given a constant average rate of change, y equals f of x with respect to x, which is known as m, the slope, a linear function can be used to model the relationship between the variables. Y equals f of x equals mx plus b. B, or f of 0, is the y-intercept. Here's example 1. As dry air moves upward, it expands and cools if the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius. Express the temperature T, capital T, in degrees Celsius as a function of the height h in kilometers. Assuming that a linear model is appropriate, draw the graph of the function. What does the slope represent. So first and foremost, we are going to write h comma t. Remember, normally we have x comma y, and at the ground level, the height is 0, the temperature is 20 degrees Celsius. When the height is 1 kilometer, the temperature is 10 degrees Celsius. So in order to find the equation of line, the linear equation, first we need the slope rise over run. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. However, we are using h and t. Therefore, it's t sub 2 minus t sub 1 over h sub 2 minus h sub 1. I wanted you to see the basic formula that we use and then expand it for h and t. Therefore, we are going to say 10 minus 20 over 1 minus 0. 10 minus 20 is negative 10 over 1 is negative 10. Units of the numerator in degrees Celsius over the units of the denominator, height in kilometers. That's why minus 10 degrees Celsius per kilometer. And remember, when we have the y-intercept, we use y equals mx plus b. So therefore, we are going to use exactly the same thing. Instead of y, we are going to say t equals m minus 10. Instead of x, we're going to say h minus 10h plus b, which is 20. So I want you to compare and contrast and be able to come up with your own equation. However, we are using different variables. So I'm going to put the parentheses x comma y at top of h and t, so makes it easier to follow all of these formulas. Now, we have the y-intercept, and we're going to call it now the t-intercept at 0, 20. And I hope you see that if you set this one equal to 0, h becomes 2. So at the height of 2 kilometers, the temperature is 0. So we have these two pairs, again, 0, 20. We already have it, and it's been given. And we just calculated the x-intercept. We're going to call it the h-intercept. And if we plot those two pairs, you connect them, and that's the line. We don't go on the negative side of h as far as the height is concerned, because it's at the ground level it's 0, and the rest is above that, it's positive. The scale along the h and t, they don't have to be the same. The height in kilometers, and I can write that for you. And this is degrees Celsius. So the slope, we found it to be negative 10 degrees Celsius per kilometer. H represents the rate of change of temperature with respect to height. So for each kilometer, we lose 10 degrees in Celsius. So as we go up, for each kilometer that we go up, we lose this much, 10 degrees. That's why negative 10 degrees Celsius. What is the temperature at a height of 2.5 kilometers. Well, here's the t. Replace the h with 2.5. This is negative 25. Plus 20 becomes negative 5. Use the proper degrees, proper units. Minus 5 degrees centigrade, which means at the height of 2.5 kilometers, the temperature is at negative 5 degrees centigrade. Celsius, my apologies. Minus 5 degrees Celsius. Monthly cost of driving a car depends on the number of miles driven. In April, the cost was 380 bucks. The miles driven was 480 miles. In May, the cost was 460. Miles driven was 800 miles. Express the cost C as a function of the distance D. So normally we have X comma Y. In this case, we will have distance in miles, cost in dollars. So we're going to have D comma C. The blue one, 480 miles is the distance. The cost is 380. The cost is a function of distance. Light blue, 800 miles, cost $460. So this is the given information. We are going to calculate the slope, rise over run, and we're going to write y sub 2 minus y sub 1 over x sub 2 minus x sub 1. However, in this case, where we are using different variables, d comma c, it's going to be c sub 2 minus c sub 1 over d sub 2 minus d sub 1. Therefore, we are going to say 460 minus 380 over 800 minus 480, which is 80 over 320, which is 1/4. Now, y minus y1 equals m times x minus x sub 1. So in this case, we are going to say c minus c sub 1 equals m times d minus d sub 1. So you can use one of these two pairs. For example, if we use this one, we say c minus 460 equals m 1/4 times d minus 800. We're using this and changing the variables to d and c. So the right side is 1/4 d minus 200. We are going to add this plus 460 and we get c equals 1/4 of d plus 260. So the equation is erase, fix this one. One-fourth of D plus 260. What is the cost of driving 1,500 miles per month? So that means replace the D with 1,500. So one-fourth of 1,500 we get 375 plus 260, $635. So if we drive 1,500 miles, it's going to cost $635. Draw the graph of the function. What does the slope represent? It's easy to pick up a couple of pairs that are given, 480 and 380, 800 and 460. Or if you go with this, 0, 260 is here, and then 1,000, if you plug in 1,000, one-fourth of that, that's an easy number, is 250 with 260 is 510. So it's a little bit more than 500. And then try it. And of course, we don't have it on the negative side, okay? Because the negative side represents negative distance. So x and y, this x represents the distance, and this y represents the cost. Now the slope of one-fourth of a dollar, okay, represents the amount of increase in cost for every mile driven. In other words, this is the fixed cost, and one-fourth for every mile will be added. What does the c-intercept, instead of the y-intercept, we're going to call it the c-intercept, represent? It represents the fixed cost. In other words, the c-intercept represents the fixed cost of operations, which is $260, because you have fixed monthly costs such as insurance and car payments, as well as costs that increase as you drive, such as gas, oil, and tires, and the cost of these for each additional mile driven is a constant. That's the, of course, assumption. It's a linear function. The cost C in dollars of a cellular phone plan is given by the function C of x equals 0.3x plus 7, where x is the number of minutes used. What is the cost of the plan if you talk for 150 minutes? Simply put, replace the x with 150. There's 1.10. They cancel each other. 3 times 15 is 45. Plus 7 is $52. If the bill is $220, how many minutes were used? So the cost is given as 220. So replace the cost with $220. And we're going to subtract 7 and divide by 0.3. So 220 minus 7 divided by 0.3. We don't want to have a decimal in the denominator, so we change it to 2,130 divided by 3. 2,100 gives you 700, 30 gives you 10, so 710 minutes. X equals 710 minutes. Pretty straightforward, everybody. What is the maximum number of minutes that can be used for $120? So C of X is given as $120 and X is missing. So again, we're going to subtract 7 and again divide by 0.3. And it gives us an approximation. So we get X equals 376.67. And what is the maximum number of minutes? Stops at this point, 376 minutes. You are not going to round this because the way they are asking us, we are not rounding it. What is the maximum number of minutes that we can use? Again, be careful as to what you do and why you do that. Book value. Book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate their assets using straight line depreciation so that the value of the asset declines by a fixed amount each year. The amount of the decline depends on the useful life that the company places on the asset. Suppose that a company just purchased a fleet of new cars for its sales force at the cost of $28,000 per car. The company chooses to depreciate each vehicle using the straight line method over 7 years. This means that each car will depreciate by $28,000 over 7 equals $4,000 per year. Part A. Write a linear function that expresses the book value V of each car as a function of its age, x. So, in short, what's going on? A car which is worth $28,000, basically over the course of 7 years, it loses all its values. That's the idea, which means if it's going to lose all its values over the course of 7 years, then $28,000 divided by 7 is the depreciation per year. That means the slope. So if we use f of x equals mx plus b, now we are going to say v of x equals mx plus b. What is m? 4,000, but it's depreciating, so it's negative 4,000. So one more time. This is the value of m. How do we know it's negative? Because if it increases, it's positive. If it decreases, it's negative. So minus 4,000 x. And what was the original value? The y-intercept. In this case, the v-intercept is $28,000. So v of x is minus 4,000 x plus 28,000. That's what we begin with. Graph the linear function. Well, basically we have this one as 0, 28,000. That's the y-intercept. In this case, we're going to call it the v-intercept. Also, if we set this equal to 0, that's an easy calculation. If you set this equal to 0, then $4,000 equals 28,000, x becomes 7. So over the course of 7 years, it loses its complete value. So we have the following two pairs and the graph. Okay. Now, what is the book value v of each car after 3 years? So replace the x with 3 times minus 4,000 is minus 12,000 plus 28,000 is 16,000. So I hope everybody can see this is negative 12,000. Interpret the slope. What does that mean? The slope is the average rate of change and it's negative $4,000. So this means that for each additional year that passes, the book value of the car decreases by $4,000. Where is the book value? V of each car, $8,000. So go back to this and replace the V with 8,000. I'm going to move the 28,000 becomes negative. 28,000 and 8,000, they add up to negative 20,000. So this goes away. Divide by negative 4,000 and we get 5. So in 5 years, the book value goes down to $8,000 from the original amount of 28K. Goes down to 8K. So X is 5. The quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of a product that consumers are willing to purchase at a given price. Suppose that the quantity supplied S and quantity demanded D of cellular telephones each month are given by the following functions, where P is the price in dollars of the telephone. So S of P is 60p minus 900, D of P is minus 15p plus 2850. The equilibrium price of a product is defined as the price at which quantity supplied equals quantity demanded. That is, the equilibrium price is the price at which S of P equals D of P. Find the equilibrium price of cellular telephones. What is the equilibrium quantity and the amount demanded or supplied at the equilibrium price? Well, so we said the two equal. It's important to understand the meaning of this. S is the supply, D is the demand, and in short, the suppliers and those who are purchasing, okay, people, they come to an agreement that is the price that will do the job. Therefore, everything provided and supplied by the company will be consumed by the consumer. So we set this equal S of P equals D of P, which means 60p minus 900 equals minus 15p plus 2850, and we solve that. Now, we're going to move things around. So this moves this way, becomes positive. It's 60p, 75p. Negative 900 moves, becomes positive 900, and we get 3750. On the right, we divide both sides by 75, and P becomes 50. That is the equilibrium price. That is where the price is set such that in essence, everybody is happy. Those who are providing and making the product and those who are consuming. That's called the equilibrium price. Now, what is the equilibrium quantity? The amount demanded or supplied at the equilibrium price. We want to find the equilibrium point. If we plug in this number 50, to S of P or to D of P, either this one or this one, it must give us the same answer. In fact, 60 times 50 minus 900 is 3000 minus 900 is 2100. I highly recommend you plug it into D of P also, minus 15 times 50 plus 2850. Make sure both of them will give you the same answer, otherwise it's wrong. You must check by putting this number, this 50, into both, and they both must give you the same answer. Therefore, the equilibrium point has coordinates 50, 2100. 50 is the price and 2100 is the number of units of the product. In this case, it's cell phone, any product that we are dealing with here. Determine the price for which quantity supplied is greater than the quantity demanded. That is, solve the inequality S of P larger than D of P. So S of P larger than D of P. We make the same move as we did here for the inequality works out the same way. So move this one this way, this one that way, meaning this becomes plus 15, this becomes plus 9. You get the same answer, 75p divided by 3750 divided by 7. You get the same answer, 50, but it's an inequality. Now p is larger than 50. What does it mean? When p is equal to 50, everybody's happy, meaning the company and the consumers. But if it's larger than 50, the company is happier, and they may not be able to sell everything that they produce. If the company charges more than 50 bucks per phone, then quantity supplied will exceed quantity demanded. In this case, the company will have excess phones in inventory. So I hope everybody is clear as to what that means. And of course, if we set this less than DFP, that means when the price is less than 50, of course, the consumer is happy, but there won't be enough products for him to buy. So we want to graph S equals S of P, D equals D of P, and label the equilibrium price where S of P is 60p minus 900 and D of P is minus 15p plus 2850. We already have the equilibrium point. We calculated the equilibrium point at 50, 2100. It should work for both of them, and it does. Now for this one, we also have 0, 15, 0. Okay. And for this one, we have 0, 2850. That means if you set this equal to 0, if you set this equal to 0, it results in 50. Okay. And so if we plot the pairs, of course, we have the equilibrium point at 50, 2100, 15, 0, 0, 2850. So that's one. That's another one. And the graph looks like that. P is the price. We can't have a negative sign. Okay, everybody. So we have a couple of pairs. We have the graphs, and when they intersect, that's the point of the equilibrium point. Price, quantity.